Okay, thank you. It is my great honor to introduce Dr. Pennock as our guest speaker. He is currently the University Distinguished Professor at the Michigan State University. He is in the Department of Philosophy in the track of History, Philosophy, and Sociology of Science. I met Dr. Pennock in the Asia Pacific Research Integrity Network meeting in March in Waseda University, Tokyo, where we were in the same breakout group to talk about the impact of generative AI like ChatGPT on research and learning. And I have the privilege to have the lunch with him from his invited talk in that conference the next day. And from my personal encounter, I know he's interested in character virtues such as honesty, courage, curiosity that are so important for excellence in scientific research. In particular, he likes to explore how educators can do better in helping science students cultivate these virtues. We know that the traditional training of responsible conduct research, so-called 台湾学术伦理教育, emphasize compliance with rules about what to do or what not to do. Dr. Pennock considered the training should be based on scientific values and integrity, which require researchers to internalize them and in their value system and practice these virtues in their daily research work. On behalf of AREE, 教育部台湾学术伦理教育资源中心，台湾学术伦理教育学会，国立阳明交通大学人文与社会研究中心。I would like to express my gratitude to Dr. Pennock for giving us a more comprehensive introduction on his NSF-supported project called Vocational Virtues Project, so we can know better about how he leads this project and what they have found so far. Let's welcome Dr. Pennock. It's your turn.
Thank you very much for that introduction. I'll just say to everyone that it was definitely a pleasure to meet with people here, especially at the Asia Pacific Research Conference, which had really researchers and people working on research integrity from around the area, from not only Taiwan and Japan and the whole area. Very interesting international conference and so on. And I'm extra pleased really to get this chance to speak with you today about some of the work that my group has been doing and to share some of that with you. So let me just share my screen here so I can have you see the slides, and then we'll get started. All right, I hope that works. Maybe you could just give me a signal that you're able to see my slides. I hope that's working. It looks as though it is. Perfect. So what I'm going to do today is give you an overview of a new approach that we've been working on really for the last 20 years or so, and getting more in depth in thinking about how to apply it. And the idea in general, I'll just give you an overview now, is to think about what we do as scientists or as physicians, engineers, whatever professional vocation we're in, and to think about what are the character traits, what are the character virtues that are constitutive of that make up that practice, with the idea that if we could come to understand what those are, that will give us a framework for thinking about what it means to be ethical in that professional practice. And I would say that also gives us an understanding about how to be excellent in that practice. So that's the general goal for this. Part of this comes from theoretical work that I've done as a philosopher. The book that you see here, An Instinct for Truth, Curiosity, and the Moral Character of Science, lays out some of that philosophical basis for this. And I'll give you a little bit of an explanation about where that comes from, and really also the meaning of the title of the book. And then we'll go into some of the empirical basis upon which that's built, and then an application showing which we could use this for teaching about responsible conduct in our practices. So, the project has a number of different parts, and I'll just give you this image here to show you some of the elements before going on. The project as a whole, I call the Vocational Virtue Project. And I think of this using the term vocations rather than just professions, because I want this to be seen as something where the term includes something that's more than just your career, more than just your professional job, but something that you think of as having a calling. The term vocation incorporates the root term to be called to something. It's often used in religious contexts, but really it has a much broader meaning. And here I'm using it in sort of a philosophical sense of saying that this practice, this disciplinary practice, is something that has what I would say philosophically has a normative structure, has a moral structure built into that practice. And the goal here is to analyze what those vocations come to, right? And different vocations will have different values that come along with them. And this overarching project has then looked at particular vocations in more detail. And the second row here indicates the ones that we've paid most attention to. The one on the left is a representation of engineering, those in the vocation of building things, of making things, of creating new things. The one in the middle is the one I will mostly talk about, which is the vocation of science, finding things out, discovering things about the world. And I'll say more in detail about that later. And the one on the right is medical practice. And there, the calling is to heal, to provide help, medical therapy, help to those who are sick and so on. Each of these are professional roles, practices that come with specific methods, knowledge, skills that you need to develop. And the claim of this from a philosophical point of view is that those are not just factual issues, but issues that also have a moral component, have a normative component to them. And that's what the bottom list is about. And I'll go through many of these things. But this idea of a vocation is going to be a concept, so we understand what that means. I'm then going to talk about this idea of virtue, and I'll explain something about the philosophical notion of that term. There is an area of ethics, a form of ethics that's known as virtue theory, and I'll say a little bit about what that is, and then how it is that I've worked to take virtue theory in its broad sense, and then to focus down on the virtues of vocations. And then we'll hone in and focus on science as the example of this. And there I'm going to be talking about what's especially important for scientific practice. And that's going to have to do with the idea of veracity, the idea of truth-seeking. The other thing that's important for science will have to do with verification, the testing of your conclusions. And my framework for this is to say these issues have a value component. It's often the case that you separate out facts from values, but my contention here is that the way in which we practice this, or should practice this, has a value component that provides a basis for the factual reasoning. Verisimilitude is the more unusual term that has to do with the relation of sameness. And I'm not going to get into that as much here. That's a little more technical part with the philosophy of science. But this is just to say that there's some philosophical concepts that I'm going to be talking about, all of which sort of provide the basis for understanding these professional, vocational practices, which is what we're going to be interested in. What is it that we ought to do as a scientist, or as an engineer, or as a health provider, to do that better, to do that with integrity, and to do it with excellence. That's what our goal here. Let me just start off to introduce this with a cartoon. This is a cartoon from American Scientist magazine from a number of years ago, from the cartoonist Sidney Harris, who was very reflective about what was going on and the kind of controversies and kind of amusing things sometimes about science as a practice. And here you see two scientists working in their lab with their test tubes and so on, and a number of people in the background looking over their shoulder. And you see the one scientist saying to the other, "I find it harder and harder to get any work done with all the ethicists hanging around." And if you're a scientist, I think you've probably heard others expressing something along these lines. It seems as though the ethicists are coming in and interfering with research. They're watching you over your shoulder and saying, "Don't do this," or "Maybe you shouldn't do that." And the negative view of this is that it's interfering with research. And part of what I hope we'll get by the end of this is a reversal of that, so that we recognize that if you really understand ethics in the way that I'm suggesting from this virtue theoretic perspective, that you'll see it not as something that's outside looking in and interfering with science, but rather something that is internal to the practice, and that supports it and makes it better. So I think that what we're seeing here in this cartoon is a reflection of how we're not doing this very well, and I hope that this new approach can help correct that. That's going to be our goal. Now, I'm going to here just mention the way in which this frame of responsible conduct of research is institutionalized in the United States. So this is just one example, but it's a major one that people deal with here. It's from the National Science Foundation, which is one of the main federal agencies which provides funding for scientific research. So any scientist looking to get a grant, National Science Foundation, NSF, is where you apply, try to get money to fund your research. A number of years ago, 2010, NSF put into place a requirement for RCR, which means responsible conduct of research. Okay? It's essentially an ethics requirement. And here's the way they phrased it in their documents. The NSF director shall require that every institution that applies for financial assistance, that's to say for grants, from the foundation for science and engineering research or education, that they describe in your grant proposal a plan. So any grant proposal is going to have a plan to provide appropriate training and oversight in the responsible and ethical conduct of research to who? Undergraduate students, graduate students, postdoctoral researchers, anyone who is being trained as a participant under the proposed research project. Okay. The part here in red is the key one. Provide appropriate training and oversight in the responsible and ethical conduct of research. And usually this is just abbreviated as responsible conduct of research, RCR. That's where that comes from. So for many years now, this has been something that scientists who are grant funded have had to think about and build into their efforts. Now, what do we mean, or what do they mean by responsible conduct of research? So here's a couple of definitions that have been in the early part of the literature. So the Office of Research Integrity is the federal branch for the United States that oversees these sorts of things. And here's what they said in an early publication. In general terms, responsible conduct in research is simply good citizenship applied to professional life. That's a very, very broad definition. It doesn't give you much conduct, but it has to do with the idea that you are in this role, not just as a researcher, but as someone who participates, right, as a citizen with others as well. And the idea is that those social responsibilities need to be incorporated into your professional research. Okay, so that's pretty broad still. Others have tried to be a little more specific. So here's the way it was described by the Council of Graduate Schools. So after this was put into place as a requirement, the universities realized that they had to have ways of supporting scientists in their grant funding to tell them, here's what you're going to need to do. And here's how they defined it, again, in a general sense. The term RCR may be used in this wider sense to include all possible aspects of individual character and behavior that impact research. Okay. Now, I'm highlighting this because I want to pull out both of those points that are in red. Character and behavior. Okay. And if you look, as we'll see in a minute, as to the content of most of the training programs, is that it almost all deals with the second part, behavior. What should we do? What shouldn't we do? What are the rules to follow? What are the prohibitions of things you can't do? Those are all behavioral guidelines. Okay. But they did mention this idea of character. It's just that there hasn't been very much work on that. Almost all the work has been on behavior. And the approach that I'm going to be talking about and recommending is one that says we should also be paying attention to character. That's to say, the qualities of the researcher, the character of the researcher. And it's not that these are alternatives, it's that they, I would say, go together. And you can't really do one without the other. You're going to have to bring them together. And the goal here is to bring up the character part, which has been neglected, so that it would better support the other part having to do with behavior. And I hope you'll see by the end of this as to how that will work and why it's important. Okay, let's just get a brief history about where this whole approach came from of RCR and why it is that that was instituted in the first place. Okay. It really started because of historical reasons where scientists did things that were seen to be morally atrocious, morally unacceptable. Okay. And specifically, it came out of World War II and the experimentation that Nazis did, medical experiments upon prisoners and so on. That was seen as something where those physicians, those medical researchers, and so on, did something that was beyond the ethical pale. And there are other cases, like in the United States, this famous case of the Tuskegee syphilis study, of a study of this sexually transmitted disease, where people who came to be treated were not all treated. Some were put into a placebo group and not told about this, and actually were not given treatment in order to study what the effects would be of non-treatment compared to treatment and so on. And after the fact, this was recognized as something that was unethical and so on. It was these kinds of bad cases which then led to the requirement to say, we need to put in place some legislative requirements. So the National Science Foundation, but also NIH in the United States, which is the National Institutes of Health. And that's the grant-making agency that funds medical research. Both those groups put into place these requirements that anyone who's to be funded would have to include responsible conduct of research, RCR training, for any of their participants. So why do we do it? One is to prevent these atrocities. Two is because we're required to do so by law. Okay? But from a philosophical point of view, it's this last point that's the important one. The reason for doing them is because it provides a basis for having better science and a basis for being better for science. Okay? It's partly what makes science trustworthy. Okay? Both internally, which is to say we as researchers can trust the results, but also externally, that society and those who might use or adopt scientific results can find those to be something that's trustworthy as well. And that's, I would argue, the ethical basis that we want to start with. The reason for doing these things is because it makes us better as scientists, it makes science better, and it makes science better to serve society, makes it more trustworthy. Okay? And from a philosophical and ethical point of view, that I would argue is the basis for why we do it. The compliance with rules, I mean, that's a legal requirement. Preventing atrocities, of course, is just a subset of doing things ethically and so on. We don't want to do things that are harmful and so on. But it's this basic notion that we want to try to understand better. Now, what about the topics? If you take a look beyond just those general points that I mentioned before, people started to, researchers, scholars, ethicists, started to make lists. Okay, but most of them really are about behavior. Okay, so a very important early work by Pimple in 2002 identified what he called 6 general domains for RCR. So the first having to do with just the integrity of science. Second group having to do with relationships among researchers, being collegial and how they interact with each other. Another category having to do with the protection of human subjects, and you can see how this arose from what was mentioned before, the atrocities and so on. The idea was anything that science does with regard to human subjects needs to make sure that they're treated ethically, protects them. But not just human beings, also animals. And so this area of animal welfare, many scientific and especially medical research studies require doing experiments on animals. And the point of this domain was that the way in which we do this ought to be cognizant of animal well-being too. The fifth area had to do with the institutional structures that support science, scientific societies, professional groupings, the universities within which researchers work, the agencies that fund them, the industries that make use of them, all of these having to do with institutional structures. And then finally, the domain of social responsibility, how what scientists do owe or are responsive to social well-being overall. So this goes a little bit more beyond just those narrow things we talked about before, citizenship, character and behavior, and it's starting to spell things out in a little more detail. The Office of Research Integrity, this is ORI, which I had mentioned before, they honed in on some more specific things. And they said, here are nine core areas. And I'm sure many of you are familiar with many of these things. Ethics in relationship to how data is acquired, how it's managed, how it's shared, who owns it. These are things where there are some rules that need to be followed to make sure that we're doing this in an ethical way. In any training relationship, there's ethics in relationship to the person who is the teacher or the trainer or the lab overseer and those who are the students or the trainees or the staff. Okay, those relationships have an ethical component where we need to make sure that proper responsibility is taken in your role. Issues having to do with the publication of results. It's more and more the case that it's not a single researcher, but a group of researchers. Well, how should those be credited? When you're publishing a paper, there's a list of authors. Who should be included? Who does not need to be included? Who should be listed first or last or whatever? These are things having to do with receiving credit for one's work. One of my earliest papers, actually, in ethics and responsible conduct of research, had to do with this issue of responsible authorship, because I was noticing that there was more and more large collaborative research that was being done. And in those cases, sometimes you would have dozens, or some cases with physics, 100 or more people who are authors. And the question then had to do with who's being credited, but also who's taking responsibility for what. And ethics gives us, I would say, some guidance as to how to do this in a way that properly is just with regard to credit, but also to potential blame if something goes wrong. Issues having to do with peer review, the assessment and judgment of a publication before or submission to publication. Things having to do with collaboration, again, with human subjects, animals, misconduct of various sorts, conflicts of interest. If you're paid by one group that might be wanting a particular result. These are things that the Office of Research Integrity said all fall under the scope of responsible conduct. And I'm just going to do one more to sort of show you how far this has gotten. A 2009 paper by Dubois and Decker expanded this even further and had over 250 topics and subtopics and so on. So there's a lot of detail that one can get into. And the whole literature, of course, covers this in more and more fine-grained ways. To the degree that it becomes really too complex for most people to be able to follow everything, of course. And certainly with regard to training, it's more than is manageable and so on. And in each case, as you can sort of see, these things all involve, behaviors, what you should and shouldn't do with regard to these things. So it's focusing on that second aspect. And in many cases, it had to do with laws, regulations that had to be followed. Obviously, different countries have different specific laws. And often when we're training students in responsible conduct, that's the first thing we think of. What are the laws in our area that we have to follow? And of course, those are important. But I would argue that that's not the basis for what responsible conduct is. That's just one of the constraints that you have to properly pay attention to. But science as a practice, as a vocation, has its own internal structure of moral do's and don'ts, and that's what we're going to be looking at. That's what I would say is the frame within which we should see these other things. And that has to do with character. Now, just a little more about how this is typically done. And I'm sure some of you have encountered this. Some of you have probably led things of this sort. How do we teach about responsible conduct of research? The Asia Pacific Research Integrity Conference that was mentioned that we attended is just one of now a number of conferences that are held internationally. The other main one is the World Conference on Research Integrity. It's held every other year. Hong Kong, last one was in South Africa, previously in Amsterdam. It's really held all over. And it has to do with researchers coming together from around the world, essentially to talk about these issues and help to improve the way in which we teach about RCR. So how is it done? Here's just a list of some common ways that have been implemented. Formal modes of instruction initially were done by professional organizations, scientific organizations, in recognizing that they needed to pay attention to ethics, wrote up codes. Said, if you are an engineer, here's the code of ethics that you ought to adopt and are responsible for following as a member of that profession. Different scientific organizations have codes of ethics. I actually have a project now with a postdoc in my group where we've been collecting statements, codes of ethics from across the different scientific societies and so on, to just get a synoptic view of all the sorts of ways in which those have been articulated historically. Some of them are very broad, some of them are in great depth, and typically, if you become a member of some profession, could consult that and really ought to see that as part of the responsibility that you're taking on. So that's a way of articulating this that many organizations have thought of. And most of those things do involve the kinds of things we've been talking about. Here's what it means to be a member of this. Here's what we expect. Here's the ethical principles that should be followed. The other mode, though, is not at the point that you become officially a member of that profession, but it's during the training. And this is what happens as a student, right? Through textbooks, classrooms. In this way, you have workshops, you might be given case studies, terms are defined, you're introduced to laws and principles and rules. Anyone who's been in medical training, you've probably taken something that's involved medical ethics, and you might very well have encountered a textbook, Principles of Medical Ethics, and learned some basic ethical principles that are then explained and help you provide a framework for what you should or shouldn't do. Principles of non-maleficence, don't harm. Principles of beneficence, do good. Principles of justice, and so on. And these are very standard for part of training. In other cases, you use cases. You teach the ethics through examples. Often they're puzzles, ethical puzzles, where you say, here's a case, and you describe some situation, and the idea is to figure out what's called casuistry, analysis of cases, what one ought to do to solve this ethical puzzle. Now, not every profession or not every training program can do a whole class on this, so some of them just have workshops. And universities have now set up, Michigan State University offers these workshops, something where you're required to take a certain number of hours to learn about ethics in one way or another. I suspect that for many of you, this very talk that we're having now qualifies for you as a workshop session where you'll get some credit for this. So that's a very common sort of formal mechanism that's been and of course, there's plenty of information on the web. It's not always easy to find, even if you go to societies and so on, when we were looking for the codes of ethics and so on, it was often buried away and difficult to find what the ethical expectations were and so on. But they're often out there. So. The other part, though, is informal. And this is, I think, in a way, much more important as part of the way that we're trained, which is not what happens just in the classroom, but especially in graduate school, what happens through the relationship, the mentoring relationship that you have with your advisor, the person that you train with, in whatever field you're in. Through the role modeling, through discussions that you have, tell stories, you kind of absorb this as part of your training in an informal way. Okay? Sometimes there are semi-formal things where there might be a journal club where they discuss something and so on. But that happens, all these things happen in a much smaller group in a way that's part of your almost apprenticeship. So, now, I'm going to argue that actually some of the informal ones are more important, and part of what's been an issue is that the emphasis has swung to the formal instruction, thinking, oh, we need to make sure that we check off these boxes and comply with the rules. And part of the problem is that that's led to a circumstance that reflects the cartoon, where scientists or practitioners think of this as something that's imposed upon them. It's a compliance issue, something you must fulfill, checking off the boxes. This is partly what's led to the issue that we're in. In some cases, it just happens by trial and error. You have the ethics things, the courses, you put these in, the role playing and so on. These are general approaches. But when done in this compliance-based way, they're not as effective as we would hope. And there's, in the literature, criticisms of the way in which we've done it. So here are some of the standard critiques that one finds in the scholarly literature to the way in which training is typically carried out. And this is another paper that another postdoc of mine in our group has been going through. We're about ready to publish this, we hope, surveying the literature to sort of see what are the ways in which it's done and what are some of the criticisms, and then how our virtue-based approach might be able to correct some of these things. But here's some of the criticisms that one typically sees in the literature. That the kind of training that we do is onerous. It's thought of as administrative bureaucracy. It's a hoop that you have to jump through, right? You've got to do 3 hours of this, and it takes up time that you'd rather be spending doing your research, okay? Taking away from it. There's also criticism that it doesn't really work. It's ineffective. It's over and it's done. We don't remember it. It doesn't actually make a difference to us. It's not very helpful when it comes to the actual practices that you're supposed to do. You're confronted with some actual ethical dilemma in real life, and what you've learned is so vague that it doesn't apply in a very straightforward way. You haven't developed the judgment that you need in order to be able to figure out in a particular circumstance what the right thing is. And this is something that philosophers talk about quite a bit, that rules, although they're important, have limitations, that it's very difficult to write a rule that's precise enough and also general enough so that you know how to apply it in all circumstances or difficult circumstances. And part of what you have to do in order to be able to learn to do that is to develop ethical judgment. Okay? You have to be able to know what these rules are supposed to do, how they work, so that you're able to figure out how to apply them in particular cases. That's moral judgment. Okay? And typically the training that we do isn't very good at developing that judgment. And then the third criticism, general criticism, is one that we've made ourselves, is that this feels like an external imposition. Okay? the RCR training requirements seem like they're legalistic. You must do this, you must do this. It's the ethics police coming in to constrain your work and so on. It feels like it's coming from without. So these are reasons that not only would they not be remembered, but they might even be resented as something that's a hindrance to research. So our hope would be that we could find a way to relieve and correct the training so that we don't suffer from these problems. And that's what our Scientific Virtues Project is an attempt to do. To show that a vocational virtue-based approach can help transform the way we think about our practices, our vocations, so that we see this as something that allows us to know how to regard our practice, how to better ourselves, how to cultivate the traits that will make us more ethical, to have more integrity, and really to be better, to be more excellent at our work. That's going to be the goal. Now, there are different aspects to this project, and I'm just going to go through sort of overall the three things that we've done. The first is a theoretical approach. So this is the philosophy, and this is the work that I alluded to at the beginning that I've been doing, having to do with the normative structure, to think philosophically, ethically, with regard to history and to real circumstances, but to think about how would one justify and understand from a philosophical point of view what those requirements are, how to think about ethics in this kind of context. And the book that I mentioned that showed up front is really an attempt to sort of give some of that philosophical framework. And I'll tell you a bit more about this in just a bit. The second aspect is to then test that framework, to test that theory with some data. Okay? And so part of what the project has done is to do an empirical study, a formal study, where we've actually interviewed scientists and asked them about their ethical perspectives to see if the framework, the virtue-based framework that we've advanced, actually resonates and is seen as authentic. And then to try to get from them their own accounts, their own ways of expressing this, their own stories, to sort of show how this is discussed and how it might be passed on in real contexts. And then finally, to take all of these in a practical way and to try to design a curriculum, courses, workshops, materials that would provide a responsible conduct of research form of training that's based upon this idea of vocational character virtues, with the idea of having that as a complement to the rule-based approach, which would then support those and be seen as something that's internal rather than imposed from without. And I'm going to talk about each of these in turn so you can see what we've done. All right, so let's start with the first part, the theoretical aspect of virtue theory and vocational virtue theory in particular. So my own work as a philosopher of science has been initially on what philosophers of science typically do, which is to think about the nature of scientific practice, looking at the theories, the notions of explanation, the methods, and so on. Philosophy of science mostly deals with those sorts of things, which for the people who don't do it, it seems a little strange because we always think internally about this as analyzing the concepts that make up something. So philosophers of science mostly focus on scientific concepts, so on. The ethics of something is, including the ethics of science, is typically something that's more part of ethics rather than part of philosophy of science. But what I'm arguing here is that we can incorporate this idea of philosophy of science, understanding its methods and practices, and transition into what it means to have a philosophy of the scientist, okay, as a practitioner of that method. And that has to do with the character of the scientist. So here the idea is there's a connection between the character of science and the character of the scientist. And what virtue theory does, and specifically what vocational virtue theory does, is try to show their connectedness. And that's what I'm going to do now. So this, I'll just give you a little personal notion of where I got started on this. To me, my other research has been on evolutionary biology. And I do research on how it is that we evolve to be cognitive beings, right? How evolution produces the ability in us to know about the world, okay? And I think that what evolutionary biology has done is actually given us tools and a framework, scientific framework, to explain and to begin to explain these sorts of qualities and so on. But they're not everyone accepts evolution. And in the United States, there's a group, religious-based group, that has opposed evolution for decades, really, and insists that evolution didn't happen, but rather God directly created human beings and the world beforehand. And so there's always been this conflict. Some of you may know a little of the history of this and so on. And one thinks that it's over and so on, but it does continue to come back. And I was involved a number of years ago with one of the most recent incarnations of this, which was called intelligent design. And this form of creationism tried to get around what had been court cases before that had said, you can't teach this as science, this is religion. And this has to do with a very particular American circumstance where you have these objections that want to bring in a religious creation-based form and call it science. And this was a case where I was an expert witness because I had written a book to sort of show why this new form of creationism is not scientific and isn't justified and so on. And in my research for this book, part of what I recognized was that the scientists who were responding to these attacks weren't just doing it by saying that they were factually wrong. Okay, they were responding in a way where they felt, you could tell when you interviewed them, that they were feeling that there was something objectionable, there was something almost morally objectionable to this attack, that they were undermining something that was fundamental to the notion of science itself. And so they took it as something that was morally objectionable. And that's actually what led me to start thinking about, well, what is it about the nature of science that has these ethical constraints as part of its method? Okay. And that's what then led me to think about, how the methods and assumptions for how we methodologically find out things about the world scientifically relate to our character and our normative values and so on. And that then led me to think about what the character virtues are and so on. That was sort of, from my point of view, the start of this. And that led me to start thinking about virtue, okay, and what I called the scientific virtues. Right? That there's some distinctive character traits that are important to the practice of science. And let me just talk a little bit about this concept, virtue, so you can see what I have in mind. Okay, so virtue theory, this now gets into a little bit of ethical theory. Virtue theory has a long history, and I'm just going to focus on one root of it. One can find roots in other ways as well, including other cultural roots and so on. But I'm just going to focus on Aristotle because that's a root that works very well for this. Aristotle was someone who was interested in both understanding the world empirically, but also understanding how we ought to behave ethically and so on. And this is from his work where he's thinking about the ethics. And he thinks of a virtue in a way that's a little different, maybe from the way in which we use the term now, but one that I think works very well. A virtue is, he said, a settled disposition of the mind. And that's sort of a technical notion here, but the idea here is it's a mental trait, a character trait that has to do with the way you think, okay? That disposes you, right, that makes it so that you will act because of the way that your mindset is, okay? Disposition of the mind that determines our choice of actions and the way we feel about them, our emotions. Okay? So it's something that has a basis in what I would call a mindset. So it's a way of thinking. And the idea here is this is something that if you have this virtue, this trait, that will dispose you to act in certain ways and to feel certain ways in response to something. That's the general idea of what a virtue is. And Aristotle analyzes this in relationship to what he thinks of as the human purpose. The Greek term here is telos, but it really means aim or purpose or goal. And what Aristotle says is human beings have a purpose, and the virtues that we ought to cultivate are the ones then that will lead us to better achieve that purpose. Well, what is the human purpose according to Aristotle? Aristotle has here now a notion, an analysis of what a human being is that comes from his empirical side. But he thinks of us as being animals, okay? But a specific kind of animal. We're a rational animal. That's what's distinctive about us. Human beings are animals that have a certain capacity for mental thought, contemplation, so on. And he thought that our purpose was the actualization of that distinctively human potential. Okay? And what we ought to do to develop ourselves is to do that as well as we can, right? To make whole and to accentuate the potential that we have to be rational animals. Okay? That's what we're after. And the virtues are those things that we ought to develop in order to do that well. That's the idea. Okay? Well, what happens if you do it successfully? Well, then you have eudaimonia. And sometimes that's translated as happiness, but mostly ethicists think that the better translation for English is human flourishing, okay? Being one's best human self. Right? That's the idea. And virtue theory for Aristotle says we should develop those character traits that will help us fulfill our human telos, our purpose, and that will lead to flourishing, right? We will then be actualized as human beings. That's his notion. And then he goes through and says, well, what are those virtues? And he identified 4 key virtues for human beings. Prudence, courage, justice, and temperance. Temperance being sort of a balanced notion. And his analysis of what virtue is really is related to this as well. It's a balance between extremes. To be virtuous in a way is to have this middle position where you don't have too much of a trait or too little of a trait, but really just the right amount and so on. And that helps us analyze and figure out what we ought to do in particular cases. One of his key cases, like with courage, for example, courage is the virtue. If you have too much of this trait, though, that's to be brash and reckless. So that's not a virtue, that's a vice. Or if you have too little of it, that's to be cowardly. Okay, and that's not a virtue, that's a vice as well. So Aristotle's analysis has to do with courage as being the virtuous mean, right, the golden mean between these extremes, which are not virtuous but are vicious. So anyway, he has a very well worked out way of thinking through how to figure out what the virtues are for human beings. And then he goes on to say, well, how is it that we learn them? And he says we learn them part by thinking about them, but also by looking to those others who have lived a life with experience and who have practical wisdom, right? Who've actually been able to think through and test these things and through their own experience achieved a kind of wisdom for understanding them. And we learn from those people. So he has an analysis not only of what they are and how to figure them out, but also how to learn them. So that's the general idea. And virtue theory is typically thought of as sort of one of the branches of ethics, the other branches being deontology, which has to do with one's duties. And that's usually the realm under which rules and rights and responsibilities come in. So most of what I talked about before, for the rules that we have to follow and so on, that falls under deontology. And then the other branch has to do with what's often called consequentialist or utilitarian ethics. And that has to do with analyzing what the results are of actions and a judgment of what we ought to do or not to do in terms of what the effects would be. And ethicists argue about how to see the relationship among these things and so on. But virtue theory has sort of seen a resurgence in the last several decades. And its focus is on character and the development of judgment. But as you can sort of see here, this is a notion of virtue in a very broad sense. It's what it is to be a virtuous human being. And what I want to do is say, well, let's think about this in a narrower sense. And here I'm going to quote from Aleister McIntyre, who's an ethicist, who was one of the ones to bring virtue theory back into professional interest. And here's the way that he defined virtue. He says it's an acquired human quality. It's not just something you have or don't. You can develop it. He says, and if you have it, the possession and exercise of which tends to enable us to achieve those goods, okay? And here the goods have to do with the ends, okay? It says the goods that are internal to practices, and the lack of which, if you don't have these virtues, prevents us from achieving those such goods. Okay? Now, this is the link that I used to sort of say we can apply this notion to the idea of vocation. Here the idea is a practice in a vocational sense is the discipline, the structured discipline science, or like being a healthcare provider, or being an engineer, or being an artist. Okay? And if we understand what its internal goods are, that's to say, what is the goal, the purpose, the telos of that practice, that will then allow us to understand something about what its particular virtues are. Okay? And so that's my contribution to this, thinking about it in terms of vocations, not just for us as a human being, but as a human being with a particular calling, okay, who is called to be a scientist or called to some other vocation. So let's look at this notion here. How does it work for vocational virtue theory? So I would say vocational virtues are those special dispositions. Again, they're traits, character traits, but those are the traits of the mind that are important for a disciplined practice. Disciplined practice here is this idea of a structured practice that has a methodology. There's the notion of a discipline here has to do both with the idea that it's disciplinary, it focuses on a particular topic, but also that there is a discipline to it. There is a set of constraints and practices that you have to train yourself in order to be able to accomplish it. And so one example of that would be the vocation of science. Okay? And what you're trying to develop here are those virtues, the scientific virtues that make up the scientific mindset. So essentially what I've done is take this general framework of virtue theory, but now applied it to the limited case of what the scientific vocation is. Similarly, you could then ask, well, what's the vocational telos? What's the goal of this vocation? What's the goal of science, for example? Well, here, discovering truths about the natural world, right? That's going to be, if you analyze science, that's what it's going to be about. And what is it you get? If you do it well, you'll have vocational flourishing, right? Science itself will flourish and its results will flourish. You'll get a flourishing research culture. And how do you do it? Well, you'll do it through the development of the specific, distinctive vocational virtues. For science, right, those would be the scientific virtues. Right? For engineering, you'd have the engineering mindset. There'd be the goals for engineering, and you'd have specific virtues that are related to that. Similarly for medicine. So that's what I'm recommending we do as a way of figuring out something about the responsibility for us in the practices and the vocations that we're called to. Right? So for responsible conduct of research, we should think, I'm in the vocation of being a scientist. I'm out to discover truths about the natural world. How should I cultivate traits in myself, right, and in relationship to other scientists and scientific institutions, such that in cultivating those, we will be more integrated and more excellent and have then a flourishing research culture and make it more likely that we'll achieve our end in discovering truths about the natural world. Okay, so that's the way in which we can then think about what it is that we're after. Okay, so here's sort of a pictorial overview. Right? You figure out first of all what the vocation's purpose is. Okay? Analyze its telos, the purpose of science, right? And that's going to inform you about the values, some of which are epistemic values. So what's that? Epistemic values for science have to do with values having to do with knowing things, okay? And that then provides the grounding, the justification for the specific vocational virtues that are for that purpose. And for science, there you have scientific methodology and scientific values, and that will then lead to, and one can think these through philosophically, vocational virtues that are specifically scientific, things like curiosity, like honesty, humility to evidence, objectivity. And I'm going to say a little bit about these, but those are the scientific virtues, the cultivation, the development of which will help you achieve those values and make it more likely that you'll achieve your purpose of scientist. Okay? So historically, you could find this all over the place. And because I do work in evolutionary biology, I always go to Darwin. And here's something that I found in a letter that Darwin wrote to one of his scientific colleagues when he was just reflecting about his own feeling as a scientist. And I think this is really a very revealing quotation from him. It's just looking in himself. He says, I believe there exists and I feel within me an instinct for truth or knowledge or discovery of something of the same nature as the instinct of virtue, and that having such an instinct is reason enough for scientific researches without any practical results ever ensuing from them. This is a really interesting thing. He's not saying that there shouldn't be practical results, but he's saying just the achievement of truth and knowledge and making discoveries, that by itself is reason enough for doing science and doing it well. Okay, so let me just say a little bit about these notions here. Truth, knowledge, and discovery. So I'm not going to go into much detail about this, but it's important to kind of know what he has in mind. Because today there's kind of a criticism about even the notion of truth, and the creationists that I mentioned before thought that only God can give you truth with a capital T. And that's not what science is after. Science is after just natural truths. Okay, it doesn't have to be true to perfection. It's not 100%. It's not absolute truth. Scientific truths are always truths that are true enough. They come always with a degree of probability, a degree of uncertainty. And part of what you learn as a scientist is how you assess that. You learn statistics, you learn what the error bars mean, and so on. So that when you say, here's something we know, you know it with some degree of confidence. You can say what that degree of confidence is. And say, this is true enough for these purposes, for example, here. But that's what we're after. We do want to find out true things. It's just that you have a scientific notion of what that is. It's not absolute truth. It's a scientific notion of truth. It's an inductive notion of truth. What about knowledge? Okay, well, scientific knowledge, I would say, has sort of two components, and really as a human being, there are these two components as well. One is knowing that something is so, and this is like a claim that you might make, right? We know that the Earth moves around the sun, right? That's a knowledge claim. We know that animals and other organisms evolve from other forms, right? An evolutionary knowledge. That's what we're after in science. We want to be able to make claims on the basis of evidence and on. But the other aspect has to do with being able to do things, right? Knowing how something. And part of what you do in science is learn skills and processes and methods that let you act and achieve things. So know how isn't propositional. It's not something that's linguistic. It's something that's actionable, sort of built into your body, into your skills and so on. So both of these things are important. I would actually argue that knowing how is more basic, and knowing that, the linguistic component, comes later. But we don't need to get into that. Pretty important thing. That's partly what gets us cognitively from the evolved notion of how we get knowledge about the world to then the more systematic scientific knowledge about the world. That's an important transition. And then the notion of discovery, and here again, philosophers of science have looked at this in detail. The idea of discovery, right? Even the term has to do with an uncovering, right? It's not just seeing something, but it's seeing the reason why, right? That's what you're actually doing as a scientist. You're trying to discover why something is so, what causes it, what makes it what it is. And that's the basic notion for what we're doing in scientists. We want to discover these things about the world and what makes it work, okay? Uncovering the reasons why. And that's what Darwin saw in himself, right? There's this instinct to want to do this. And part of my work as a scientist is to say how it is that evolution produces the abilities within us, right, the cognitive abilities, to become knowers about the world. Okay? And part of the research that I do empirically has to do with using evolution in a computer system where you can evolve essentially cognitive traits and see how it is that evolution produces them, in part to see how it is that evolution can give you the components that allow for a biological notion for discovering the world. And that's what we're all born with, and all organisms have that to some degree. And then what we're interested in as we get to be more mental advanced agents, how it is that we can use then systematic science to take that to the next level and so on. So I'm interested in how we become biological knowers and then how we transition into scientific knowers and so on. Curiosity is one of those traits, right? I think that there's a biological trait that has a selective advantage. And one of the projects that I'm doing now is experimental work to sort of show how the evolution of inquisitiveness can be selectively advantageous. And I think what Darwin is talking about here, when he talks about this as an instinct for truth, he really does mean that this is something that is an evolved trait. There's something within us that wants to find out about the world, that needs to find out about the world. If we're going to succeed in the complexity of the world, we better be able to figure it out. Okay? And I think that there is an instinct that drives us to do that. And one component of that is curiosity, right? We're curious. We want to figure things out. We see something and says, oh, that seems weird. And we seek it out, try to figure out why it's happening. And that could be a benefit if we can do that. The other thing that's important about this is that he does talk about this as being similar to the instinct of virtue. Okay, and the reason I think this is such an important quotation from him is that it links these two parts in just the way that I think vocational virtue theory tells us we ought to do. Right? Darwin actually wrote in The Descent of Man, his other important book after The Origin of Species, about how it is that human beings evolve, including their mental traits, and including their moral sense. And he thought that evolution provided an instinctual basis for the ability to then tell right from wrong. So he actually does link the instinctual basis for knowledge, cognitive traits, to also the instinctual basis for moral traits. And part of what I'm arguing here is that these two things actually can go together. And that if we can first understand the biological notion, that provides us a basis then for the next step of doing this systematically with the cultivation of those traits so that we can do it systematically and responsibly as scientists. That's what we're after. He talks about the instinct of virtue in terms of character traits that evolve to be helping of one another, and gives an account of how this can work, so that it's not that we're always fighting with each other, but under certain circumstances we help and are altruistic to each other. And one of the projects that I did really makes use of our evolving digital systems to show how you can get the evolution of cooperation, of altruism. You can watch it happen. Okay? I think this is actually something that he gets right, and we should take seriously. All right. So, well, what is the scientific telos? I think Darwin said it there. It's to find out truths, knowledge, discovery about the world. But let's see what some other scientists have said. Okay, that was a historical example. I could give others, but here's some examples from how current scientists say this. So here's one scientist. He says, well, in two sentences, I think probably the central guiding purpose for a scientist on a personal level is one of trying to further human understanding of some phenomenon. Okay, so some feature of the world, some phenomenon, and you want to understand it, right? Why is this so? And that's this notion of discovery. Understanding has to do with the reason why. So that's the first part, coming up with a discovery, truths about the world, understanding why. And then he says, I think ancillary to that, you would hope that that process would also lead you to something that actually helps society. Okay? Two parts here. I think there's a balance between those two things. It goes back to this innate curiosity, this desire to understand some phenomenon on a deeper level, contribute to human understanding of some phenomenon, and then, aside from that, hopefully, to have some positive benefit on your fellow man. And those, I think, are kind of the two parts here. That science is primarily interested in finding out things, new things about the world, discovering things that would then be of benefit, be of utility to us as human beings. And this is the sense in which I think of vocational virtues as being sort of a contributor to what Aristotle had as the larger project of human virtue. Right? We can't all do everything, but in our vocation, we can contribute something that helps us generally, okay? A positive benefit for humanity and for human flourishing. Here's another series of scientists all reflecting upon this, and this is all from interviews asking them, what do you think the central guiding purpose is? Can you say it in a couple sentences? So here's some other ways people have put it, scientists have put it. One thing that you see values in this career is that you're part of this arc of human history and knowledge. I guess I see that as one thing that's just exciting, as if you're actually in a profession where your goal is to make discoveries. Okay, they're saying, here's what our telos is. they are actually contributing to the scientist's role in humanity, learning more and more about the world and how it works. That's what we do as scientists. Discover something about the world with the hope that it then potentially can help humanity. Here's some others, an even simpler, straightforward way. The animating purpose of most scientists is to find or understand something new, to make a discovery, something we didn't know, to improve our understanding. Or in this other one, to understand how nature works in the broadest sense, or to discover new knowledge in order to help humanity. These are all different ways that scientists put that scientific purpose. Okay? They're all identifying this core thing about discovering truths about the natural world, and then secondarily, that those would be things that would be then helpful to us as human beings generally. So, finding true things about the natural world, that leads us to this idea of veracity, and veracity has to do with truthfulness, right? And that's really important to science. So let me say a little bit about that. Again, we're thinking now about this relationship, the scientific character, going from the methods of science, the philosophy of science, to this philosophy of the scientist and the way that they think. And that's what we're after here. So I'm just going to give you this example. This is from a number of years ago from a scientist who published this piece in Nature, top journals, of course. Andrew Line. And he and his colleagues published what they took to be the first evidence of planets orbiting distant stars. Okay, and that's what the title here is: a planet orbiting the neutron star PSR 1182910. Okay. First publication of supposed evidence of planets outside our solar system orbiting another star. Amazing discovery. So he published it, and he was preparing to give a talk about this at a professional meeting. And in preparing his talk, he went through again his paper and his data and so on to prepare his presentation. And when he did so, he realized that they had made a terrible mistake. That in their calculations, the measurements that they had taken to sort of show this movement, which they saw as the movement of the planet around a distant star, was actually congruent with the motion of the Earth in its motion around the sun. And what he realized was that that motion that they had seen was not a motion of another planet around another star, but was actually a measurement of the Earth's motion, and that they hadn't taken that into account. And they had essentially been reading in the Earth's motion and attributing that to a planet that didn't exist. That's a major mistake. And he realized this, that everything that they'd done was wrong. And here's what he said. He says, I was just completely numb for half an hour or an hour. I just sat there going through everything that I had said for the last 6 months to lots of people and realizing that it was mostly complete rubbish. And I had made a really fundamental error. He says, I had to let everyone know as soon as possible so they would not dwell on an object which did not exist, and that they would not tax their ingenuity trying to understand it. And so at his talk, at his presentation, where the whole audience of scientists was there to essentially hear his evidence for this first discovery of another planet around another star, okay, instead they heard him give an explanation of why he was wrong, okay, and an explanation of why what he thought was true wasn't, okay, that it had been a complete mistake. That's a major error, okay? And you can imagine yourself going forward and giving such a talk. The thing that I find very heartening and inspiring about this story, though, is that the reaction of the scientists in the room was to stand and give him an ovation and applause. Okay, that what he exemplified there was the basic value that they all held, namely, find the evidence for what is true. And he was exemplifying that moral trait, okay, in saying, I made this mistake, and here is the error that I made, and essentially explaining that and so on. That's an exemplification of this value of truth and how the method of science aims at validating a hypothesis, or in this case, disqualifying one, showing a mistake. And in both cases, it's doing what we want science to do, right? It's using evidence to be able to judge conclusions. And I think of this as something, and scientists who were there at the time said that they just felt very proud that this was someone who exemplified, what it meant to be a scientist, right? This basic commitment to truth and evidence. And this is exemplified in lots of ways, but here's one way of doing it very simply. Cornforth saying, scientists don't just believe, they check. Okay? You can't just have a conclusion and say, here's what it is, because you want it to be so. Not just because they believe it, it's because it's been tested after it's been checked. Okay? That's the basic notion of what science is. And that has to do with this idea of verification. Okay? And now we're back to what the commitment, the moral commitment, requires of you in terms of your methods and behavior. Checking, verification, testing, right? That's part of scientific method and practice. Okay? And so I actually wanted to do the same thing, to take this theoretical approach about virtues and to do an empirical study, to ask, hey, do scientists actually think this? Let me test my ideas and see if it fits with the way scientists themselves think about this. So let me just briefly now say a little bit about what we found and what we did in this empirical study. So this is a very large national study. It's taken many years, and we're only now at the end of doing this. But what we did was take a random sample of senior exemplary scientists and early career junior scientists and interview them, ask them, what are the important traits for being ethical and having integrity and being excellent as a scientist? And in the end, we wound up having about 1,100 scientists, a little over 600 in the senior group and a little over 500 in the junior group. It took over 4 years to collect the data. Most of our work was done with phone interviews. So we had a systematic interview protocol, group of graduate students and postdocs who conducted these interviews. Some scientists didn't want to do the phone interview, but they said I would do it online or a paper survey. So we had some data that was collected that way. We had quantitative questions that we asked, and I'll give you some of the results of that. But we also asked qualitative questions. So it's a huge data set. Most of the interviews took half an hour, 45 minutes. Some took an hour and a half, depending on what scientists had to say. So overall, over 500 hours of interviews, which we then transcribed and then coded. And all of that process took, again, several years. So we're only now the process of finishing the coding and now writing up the results. So I'm going to give you a preview of some of it. I'll give you some of the preliminary ones and then a little bit of what the final ones are. Here's some of the questions that we asked in our study. What are those virtues that are important for research? We wanted to know what they thought, see if they fit with what the ethical theory said. We wanted to know who inspired them. How did they learn? What led them to go into science, and who were their role models? We asked them how the virtues actually show up in practical ways. in the day-to-day work of science. We asked whether they thought they changed over time. We asked whether there are current social or institutional, organizational challenges that might be putting pressure upon these virtues. We also asked about scientific vices, right? Of course, as Aristotle said, right, we aim for virtue, but sometimes we can go too far and do things that are vices. So we asked, well, what are the scientific vices, the cases where scientists might go too far? We asked whether they thought that virtues could be learned or whether they were just things that you had to be born with. And then we asked how they themselves try to help their own students to cultivate those virtues. So a very rich and robust set of data that we got. And I'm just going to give you a little preview of some of these things, mostly focusing on that first thing about what the important virtues are for research. Okay. So what are the possible virtues here? So how did we do it? We start off just what I did now. I sort of said philosophically, historically, here's what we would predict them to be. Initially, I did informal interviews to just sort of do an informal check. Then we did some semi-formal ones where we had very open-ended questions to come up with a possible list. And then we did a pilot study where we narrowed it down to like 25 possible virtues. And then we had a big long list, okay, all of these things. And we asked then in this pilot set, how important are these 25 things from 0 to 10, we don't sure, and so on, and tried to figure out what are the ones that seem to be most important. And then from those, we narrowed it down to a group of 10, and our interviews with the 1,100 scientists focused on the top 10. Okay? And these are the top 10 that came out from that initial list. Okay? Attentiveness, being observant, right? Paying attention to your environment and to what you see. Being collaborative, working together with others. Having courage. This was actually something that we saw from Aristotle as one of the key human virtues and so on. Curiosity, being inquisitive. Honesty. Humility to evidence. This was an unusual one. Initially, we thought maybe humility, and that turned out to not be very important generally. But scientists said there's this particular notion of humility, which is to be subservient to what the evidence says, to what the data tell us. And that turned out to race to within the top 10. Being meticulous, being very precise and careful and checking what you're doing. Precise way, measurable way. Having objectivity, caring about what it is that the data are telling you without reading in your own subjective desires. Perseverance, which is carrying on, being patient, being perseverant in one's work. And then skepticism, which is not just accepting what someone says, but to always take it with a grain of salt until the evidence comes in. So these were like the top 10. And what we did then in the final survey was to ask, how would you rate these on a scale of 0 to 10? So I have some data on that. So the top 2 coming out of that on a scale of 0 to 10 was honesty and curiosity, with a mean of 9.7 for honesty and 9.3 for curiosity. I'm giving you here preliminary data that we've done before. We haven't published the final data yet. I'll just show you a little bit of that. So I can't show you all of that now. But this is representative, and the changes is pretty minor from the early results. So those were the top ones. The next set were being attentive, observant. Perseverance came in at 8.6, objectivity 8.6, humility to evidence, again 8.6, skepticism 8.1, and then being meticulous, averaging 7.5, courage somewhat lower, 7.2, and collaborative 6.4. Okay. So it's not just are these important, but how important are they? And that's actually something that's kind of significant. It could be, of course, that honesty is important for other vocations too. Curiosity could be important for others, but partly by giving numbers to this, you can sort of see how important are these things, so that you'll be able to see it's distinctive about science, that this is especially important, and maybe for another vocation, something else is more important. So with the final set, I'm just going to give you a couple examples from this. Curiosity and honesty continue to be the top ones. 9.31 is the mean from our total set for curiosity, 9.66 for honesty. And this is the set for the senior group. And if you look at the junior group, it's very close to that. So part of what we're going to be able to do on our final analysis is not just look at scientists as a whole, but to sort of ask, hey, you know, are those who have practical wisdom, or who've been peer identified, what do they think? But also, what do younger scientists think as well? So we can see whether there's differences, whether it might be something that you learn or improve over time, and you've got this. The other thing that we found was that there are these ones in red, these 8, which in a factor analysis hang together in a coherent way. Being collaborative and courage turn out to be less. Those were the lowest ones, as you saw, but those don't hang together in quite the same way. So there's something that's interestingly different about the ones that do fit together, and others is there being more disagreement about some of those. So for example, being collaborative might be important under some kinds of scientific work, but not for others. I can say more about that if people are interested. Here's a historical case about humility to evidence. This is one of Darwin's fellow scientists. He says, here's what you do as a scientist. You sit down before a fact as like a little child. You need to be prepared to give up every preconceived notion. You have to follow humbly wherever and to whatever abysses nature leads. You shall learn nothing. So this is the idea of what it means as a scientist, right? To be humble to the evidence, right? And that's something that's really very distinctive about science, right? Fits in with the idea of being objective, of what we need to do if we're going to find out a discovery, find out something that's true. Now, other vocations would focus on other things. I've been focusing here on science, but engineering, as you might expect, would have a different telos, and so it would have different virtues. There'll be some overlap. You need to have meticulousness, obviously, as an engineer. You're going to achieve what you do there, but an engineer isn't so much interested in making a discovery. They're more interested in building something new, right? They're interested in innovation. That's its core virtue. Similarly, if you're in the health profession, physician, a nurse, right, your central goal, guiding purpose is going to be different than science. So you'll use science, but your goal there is to help cure somebody, to provide them with care. Okay? So there too, your core virtues will emphasize different things. So this allows us, again, a framework. I've been focusing on science as the example because responsible conduct research mostly focuses on that. But it's a framework that lets us do the same thing to show what is responsible, what integrity means in other vocations as well, engineering, medicine, and so on. Okay, so here's just a quick comparison. For science, right, the telos is to discover truths about the natural world, but in medicine, the telos is to care for the sick and to promote physical health, right? Your goal there, right, what you hope to achieve, focuses on this particular end in those that you care for. The scientific virtues are those that lead to better achieving scientific telos. Curiosity is something that will help you better make discoveries. But for the medical virtues, something that will rise to the top, we would predict, would be something like empathy. If that's going to be a more important central virtue in medicine, it didn't even show up particularly on the scientific side, but in medicine, to achieve the end of caring for the sick and empathy is going to be important. The goal that you'll achieve is a flourishing research culture on the science side, but a flourishing healthcare culture on the medical side. So the idea here is knowing the vocational end, vocational telos, then helps us know what the virtues are, and cultivating those things helps us better achieve that end and flourishing overall. And then again, those contribute in their own way to human flourishing broadly. Okay? All right. Sometimes you have overlap. Okay? In general, for science, its expertise is in discovery, but if it's overlapping with something else, it might then focus on discovery with regard to that. So medical science, right, isn't just looking for general discoveries, but it's looking for general discoveries, for specific discoveries that are useful for cures, for therapy, and so on. So this essentially, we can get a more complicated, more complex analysis when you start looking at how they interact with each other. There'll be some overlapping virtues, and hopefully that'll be something we can look to see how it works in cases. And here's what our respondents say about the medical telos. Okay, this is again from our interviews. In basic science, it's a drive to understand the question that one thinks is primary. But I suppose in the medical sciences, large advances drive might be different. You're motivated to solve something for the benefit of mankind's health. Okay, that's the focus now on that particular goal. Here's another person. The scientist, again, has to have the ability to question, the ability to challenge, the tenacity and courage to pursue those challenges. And their overall goal, of course, is not just to improve knowledge, to provide humanity with tools, or with anything else that's going to improve life. And being in the life sciences and being in health, of course, the ultimate goal is to improve health and the quality of life. Overall in medicine, of course, it's for humans all. So here you're sort of seeing the slight difference now for the medical telos, but now showing up for those who do medical research. And here's just an example of something in practice. This is from an obituary. You often see the virtues described when people die. Here's what this person did, and they focus on their character more than you do in other circumstances. And here's just something from Joan Mark's obituary. She was someone who founded genetic counseling. And it just highlights that she saw this glaring need for skilled counselors, right, genetic counselors, who could explain genetics in plain language to patients. That's to say, they could explain what science, genetic science had discovered, but then to listen with empathy and guide them through a complex web of emotional, ethics, and legal choices. Okay, so this is what you do in that medical practice for your patient. So again, the vocational virtue thing allows us to analyze this. And it's all, I would argue, in terms of values. Okay? So here's another question we asked. Do you think that the values and virtues on the list can be learned? I want to know, do scientists think you just have to have them? But 94% of them said, yes, these are things we think that you can learn, that you can develop, that you can cultivate. Okay, so that's important to us, right? It's something where training, if done right, could improve this. We can get better at these things. We asked, hey, when you're judging to take on someone as a possible graduate student or postdoc, do you just look at their academic record? Or do you also try to judge what scientific character traits they might have, positive or negative, when you make your decision? And here, 12% said they only look at the academic record, but 88% said that they also try to ascertain, does this person have the character traits that you need to be better at science, to have integrity, to be excellent at science. And this is something that I think is just crucially important. It shows us that we should be paying attention to what these are and helping our students cultivate them. And that then leads us to this last part, which has to do with the creation of a curriculum. How do we do this to make it better, right? RCR training, right? How could we adapt this approach so we take the traditional thing and now supplement it with a virtue-based approach to do it better? Okay? And I think that from what we've seen, you can see why it should be that this should be helpful to us in this sort of teaching. I think it should be possible to learn it. Let's see if we can do that better. So here's just one very quick example, right? The normal way that we teach about in an RCR course about why you should not fabricate data is typically to say, well, you know, this is against the rules and it's against the law, and if you're caught, you're going to be expunged from someone. It's something you shouldn't do. So that was a virtue-based approach. Says the reason you don't fabricate data is because that goes against the very notion of what you're trying to achieve, right? Which is to make a discovery, right? You are curious about what the answer is. Curiosity to be satisfied requires honesty, requires humility to evidence, requires following what the evidence says. And the idea of making up the evidence is incoherent, is contradictory to the very telos of science. So the reason you don't fabricate data is not because someone's going to catch you, right? It's because it undermines the very thing that you're hoping to achieve, to make a discovery, to discover some truth of nature. That's the internal justification for this. And that's why it's important. Okay, so a virtue approach lets us see that clearly. And what we've developed now is this, what we call the scientific virtues toolbox. Okay? And it's a training approach that combines this theoretical part that I've been talking about with a pedagogical approach from what's called the Toolbox Dialogue Initiative. It's my collaborator, Michael O'Rourke. And what they've developed was initially something for the purpose of getting scientists from different specialties to be able to have interdisciplinary collaborations to kind of reveal their different methodological assumptions. And it was a particular way of having guided discussions to reveal those things. And what we did was take that method where they start with an instrument and they have sort of a scale about how important something is, and then prompts that the discussion revolves around, where they say, do you agree or disagree with this? And then in small group discussions, you go through these prompts and try to articulate why it is that you answered the way that they do, and to bring to the surface the values that are behind that. And that's an approach that we've then used in relationship to these virtues to develop essentially a discussion-based way of thinking about responsible conduct and the virtues that support them. Okay. So here's what we've developed so far over about a decade. We've got about 10 different workshops based upon what I've just talked about. What's the purpose of science? Right? What's the nature of curiosity and what it applies? What is it that honesty in science is about and what it involves? Courage, humility. These are the things that we've saw. And then a set of prompts that allow the discussion to bring to the surface and show how these are implemented in real circumstances and so on. And we've done some pilot data to test how this works. And I'm just going to very quickly go through some of these things. We have some scores pre and post as to how it worked. We've recorded the discussions, can analyze that, and we've done follow-up surveys. I'm just going to mention a couple of these things. For the scores, to sort of show how people change and so on, and then the surveys, things they've said after taking the workshops. So here's just a couple of examples. You initially have this instrument with the prompts and the Likert scale, and you ask, do you agree or disagree, and how strongly, and then you can check what they've done before they have the discussion, and then you have the discussion, and then they take it again and put their scores on afterwards, and then you can sort of see whether they have changed their mind as a basis of the discussion. Okay, and that's something we can then analyze, and this is something that we did in some scores, just to sort of see that the discussion really does, in some cases, change people's views. It helps them articulate them, and sometimes actually changes the way they see it. We then also had post-workshop surveys where we asked people about how they thought about it afterwards. Did you enjoy the workshop? Did you find these to be effective? And you can see the scores here are really very, very high. It's not usually the case that you get high scores for people taking these required trainings, but here we had very positive reaction. The two things that we found most interesting here are actually these ones here. Since completing the workshop, I've thought about the topics, and since completing the workshop, I've discussed the topics with others. And here we had over 60% saying that even after the workshop, they continued to think about them, and almost 50% saying that they wound up talking about them with others. And these numbers are really striking, because normally you take an RCR workshop, and then it's just you check the box and you're done. And the numbers are pretty low with regard to continuing to think, or let alone to discuss them. But here, people find them to be very interesting and worth their continued consideration and discussion. And that's how we would argue culture develops, right? It's through these relationships as people talk about them and share their views and discuss them with others. That's the role modeling and the informal development of a normative structure. So I think that's pretty important. And here's some things that they've said in response, right? These are participants from the workshops. I really like thinking about RCR in this positive way, virtues, rather than just things to avoid. I think it's a great way to get people to frame their own thoughts in a productive way. Right? The exercise was much more motivating than traditional RCR. It made me want to be a better scientist immediately. And if you think back to what I said at the beginning, right, the idea of virtue, it's a character trait that as you develop it, it provides you the inclination, the motivation to act. And that's what we sort of see here. It makes people recognize that my identity as a scientist is such that this makes me want to act better, to do better. Okay? These exercises inspire me to be an ideal scientist instead of making me worry about just what not to do wrong. This is what one wants. These are aspirational, right? It's not just on or off, it's not compliance, it's what we aim to be and to do and to develop. We asked them that they think this was going to be useful for an RCR curriculum. Definitely. I'd love it if these became the focus of RCR instead of just the traditional model. Yes, I think seizing scientific virtues as the core can produce more agreement than simply discussing a set of situational rules derived from it. Absolutely. I intend to use this approach when I teach professional ethics next spring. So very positive response and so on. So out of this preliminary data, we then developed and now have a National Science Foundation grant to bring this up at a scaled way across the university. So that's what this is. The Verities Initiative is a virtue-based education for responsibility and integrity to increase excellence in STEM. I hope you've now seen how those go together. But what this grant does is take the workshops that we developed over a decade or more and now scaling them up across the university, across departments, across colleges, and so on. And if you're interested more, if you follow the link here, you can see a little bit more about what we're doing. I'm also trying to do this nationally. So this was a workshop and conference that I put on as part of the National Sigma Xi, the Scientific Research Honor Society national meeting. And this was a poster that they developed for this part of the annual meeting with the tree of science and all its fruits arising from the trunk of integrity and its roots being these virtues: skepticism, perseverance, humility to evidence, objectivity, and so on. And the idea that we can develop and cultivate science better, the tree of knowledge, through the development of these virtues that underline and support it. And that takes us to the last part of my talk here very quickly, which is STEM education. I think this is not just something that's limited to RCR training. It's something that we ought to start to now incorporate across the scientific curriculum. When we're just teaching about science generally, we ought to be trying to cultivate curiosity in our students. Not just tell them what we've learned, but to tell them how we've learned them and to get them interested in how you learn these things as scientists so that they can ask their own questions and to be interested in the world. I think what biology provides everyone as kids is an innate, as Darwin said, an innate instinct to discover things. And it's, unfortunately, I think the way that we teach science winds up extinguishing and stomping that out. So that the kids are very interested when they're young, but then by the time they're past middle school, they're no longer, or many of them are no longer interested in science. I think we've stomped out their curiosity. So we should work more to sort of incorporate not just learning what science has found and how science has done it, but to stimulate and to spark that curiosity and the values and traits that go along with it. So you can do this at all sorts of ages. I think kids, you put them out there, they'll love to do it, and we should just make sure that that continues on. Some of my work has been to develop software and curriculums specifically for evolutionary biology so that they can do evolutionary experiments, but we don't just give them things to follow and curriculum to just go through as a rule base, but it's an open-ended system where they can themselves do evolutionary experiments and ask a question and figure out how, using these artificial life systems, to figure out the answer themselves by getting data. So we call it technology for teaching evolution and the nature of science using these digital. This is developed for undergraduate biology classes, and the link there will sort of show you that work if you're a biologist and want to incorporate this as well. We've also now started to do something for lower grades, for middle school, where again, it's learning about evolution and ecology and so on, but this is now in terms of evolving populations of salmon, and it's done as a little video game. So they learn about things and they can ask questions and figure things out and get data. But they're also learning about what the factors are that affect the population. It's fun as a game. They enjoy playing it. It becomes enjoyable. It's fun to learn about these things and to figure things out and to know what will affect the salmon, and to learn about what science can do. So you learn as part of the game, the people that you interact with are stakeholders in different STEM careers, and you can see how they contribute to our understanding. So let me just conclude here and wrap things up. Vocational virtue theory is, I think, a new framework that's useful for analyzing what the vocational norms are, to connect these to the idea of human flourishing broadly, and to cultivate what it means to cultivate a character and to teach RCR. Okay? It gives us an account that's not just theoretical, but it's backed up by empirical studies. And we now have a curriculum that puts this into action, that reconceives the way that we do RCR training, and really now a tested approach that we're scaling up both across the university and starting to be nationally. And I hope that many of you will be interested in this so that we can do this internationally as well. I've started to interview scientists in other countries. Just recently returned from Japan, and I had interviewed people there. But I think there's much more that can be done. The thing that we find, of course, is that scientists, no matter where they're from in the world, share these basic values. That's what it means to be a scientist. And I think that really we can start to implement these things, not just in RCR training, but really for science education generally. I hope that you'll help me join that. There's a whole bunch of publications that we've done that sort of support this, in case you're interested in following up on that. Here are a few that are of specific things you might start with. Paper on how to do that approach, a little bit about why, and then the theoretical part in my book. And then I just want to thank the funders here, National Science Foundation, our Beacon Center, John Templeton Foundation, and then my various colleagues and graduate students and postdocs who have been helpful with all of this. And then to thank you for your attention in this long talk. I hope it's been useful. Here's my own site and a way to contact me if you're interested in more. And with that, I thank you for your attention.
Thank you, Robert, for your talk. And so we have a little time to for the QA, and let me see whether there's some questions. Oh, there's a long there's a one. It's a long one. So Okay. Okay. So somebody, can you read it or?
Oh, should I look at this top one here that says, Dr. Pennock, thank you for your speech. Is that the one you're talking about? From Heather Tsai of the Research Center.
Yeah, Heather Tsai.
Okay, I'll briefly look at this. I don't know if other people are able to see that, but it's asking, there can be challenges in terms of aligning individual virtues with the standards of institutional legitimacy, particularly when institutional budgets are involved. Okay, of course, that's true. Different institutions may have divergent ethical principles and guidelines inwardly, which can create complexities. Okay, so the question, I guess, is in such situations, researchers may face the challenge of navigating the institutional landscape while staying true to their personal virtues. In some cases, there may be tension between the virtues researchers strive to embody and the specific policies and constraints of the institution. So that's, of course, a really important point. And that's one of the things, I didn't talk about it here, but it's one of the questions we asked in our survey. Are there institutional or social environmental things that challenge or that can make the virtues harder to implement and so on? Because we're obviously very cognizant of the fact that you can't do virtue alone. And this is something that Aristotle himself said, right? You can't be, it's hard to be virtuous in a non-virtuous or vicious circumstance, so on. And part of what virtue theory does, and I didn't talk about it so much here, but your good question here asks that, it tells us that we have to think of both parts. That what we need to do as individuals, which is what our training primarily is about, which is why I focused on this here. But virtue theory says we behave and act in these contexts. And so part of what you want to do is have institutional structures, rewards, incentives, and so on that make it more likely that virtue can be pursued and rewarded. Okay. So it actually provides us a theoretical framework for helping us improve our institutions, right? And I think that's where your good question is asking, right? How is it that we navigate these things when there's a misalignment between what we should do as individuals and what the institutions might be doing? Vocational virtue theory also tells us we can become better as institutions. And actually that's what our Verities grant is about. It's an institutional transformation grant. And the idea is, let's see if we can improve the way that we do things structurally in the institution to improve things overall, which of course is in the interest of the institutions to improve as well. So it provides us a way to improve ourselves individually, but also institutionally. And I think you have to have both things, obviously.
Okay. Although we don't have we have a little bit past the time, but I would like to ask one question.
Yes.
In your project, do you include the humanities and social sciences as in your project? And if yes, I would like to know is the domain, the principle, the domain make any difference in when they rate those virtues? Like, for example, the humanities and social sciences scientists, researchers versus the medical or natural science or engineer majors. So do you find any differences? Or is there a gender differences in rating those virtues?
So there are two parts to this. One is the theoretical part, like what would you predict to be differences? And as I sort of showed you, we would predict and expect, right, that there would be a different set of virtues emphasized for science as a vocation compared to engineering, compared to medicine, and also obviously compared to the humanities, right? If you're an artist, right, that's going to be different still. So theoretically, we've done some of this work, and empirically, the survey that I described focused on scientists, right? That's what that grant was about. And there were some who did medical research and some who did some engineering. So we have some data on that. And we did focus groups, separate focus groups on physicians and medical researchers and another focus group on engineers. So we have that as smaller comparison, but the main data set is just for scientists. So I don't have an empirical basis to the same degree that we have for science, just smaller sets and so on. So that remains to be done, but we do have some steps taken towards that, and we've also just begun to work on this with regard to the implementation. We do have, in fact, one of my graduate students at the previous World Conference spoke about some of the work we've done with the humanities virtues. And we have done work here on starting to do things with that. And that's very interesting. There's very little that's been done with regard to responsible conduct in the humanities and to social science and other sorts of areas and so on. And I think that's an area that still has a lot of interest and work that people could work on.
The gender differences? The gender.
So our focus has really been on disciplinary differences, and we haven't done an analysis yet to sort of see if gender differences. I'll just sort of see informally from doing the interviews and so on. You don't see any significant gender differences and so on. That the key things that both male and female scientists focus on is, we want to make a discovery, and here's what we do, which is what you would expect, right? This is the sense in which, right, female scientists have always said the same thing, right? That they're no different from their male colleagues in wanting to make a discovery. So I think that's kind of what you would predict.
Okay, so I know we are running out of the time, and thank you for your wonderful talk. I think we in the future we still have the chance to interact each other, and also probably invite you in person to Taiwan and give us more talks or even the workshops. So when you complete all your project and have the results, so because of the time, and the next hour will be a closed hour for you. So please stay here. And how about the host, 记者? How we arrange the online conferences? 记者。
老师他们那个就另外有博士生之后还会有另外一个连接，所以待会那个讲者他要离开这边，然后到另外一个对方开的会议室这样子。
Okay, Robert, will you have to go to another meeting room by another link? So let us close here. Okay.
All right. Thank you so much.
Thank you.
Thank you for participating in this speech, such a comprehensive and excellent talk.